Alright, so let's do 13D. I'm going to look at it a couple different ways. First way I'm going to look at it is I'm going to recognize that both sides are squared, so I'm going to square root both sides. So I will write sine of theta equals a plus or minus cosine of theta. Yes, plus or minus, because we are starting with something squared and we are square rooting something that can change, so we should include a plus or minus. And now let's think about this. What theta values will sine equal the absolute value of cosine, right? Is essentially what it's saying. Where will it equal the positive or the negative version of the cosine? Well, that can only happen, if we're thinking about the unit circle, that can only happen at the pi over 4 lines where sine is root 2 over 2 and cosine is root 2 over 2. So my solutions are going to be theta equals all those pi over 4 lines. So pi over 4, theta equals a 3 pi over 4, a theta equals a 5 pi over 4, and finally theta equals 7 pi over 4. And those would be the two solutions. When I say 2, I mean 4. I don't know why I said 2. Those would be the 4 solutions, but I want us to look at this in an additional way. So let's go back to the beginning. We'll see that we get to the same spot, but let's go back to the beginning and look at this another way. Now, another way I could do this is I could make a substitution using a Pythagorean identity. I could rewrite this as 1 minus cosine squared theta equals cosine squared, theta, by using the Pythagorean identity. Now, I can rewrite this as 1 equals, add a cosine squared theta to both sides. It's gone on the left. It's now 2 cosine squared theta on the right. Divide by 2, so we get 1/2 equals cosine squared theta. Square root both sides to get the square root of 1/2 equals a cosine of theta. Well, the square root of 1/2 is root 2 over 2. And that occurs at the pi over 4 lines, and since we square rooted, we should take plus or minus root 2 over 2. So now we see it a little more definitively why it should be those pi over 4 lines.